whole square x.
Right? Now you can write it like this. But what will you get if you write it like this?
We get
Uh,
1.
After that, what you will do? This is the denominator you are writing. Na? This denominator you are writing, if you are writing it in this form, what you will do after you do this? So because if you see, it will become sine power 4x plus sine square x minus sine power 4x plus 1 plus sine power 4x minus 2 sine square x you will get, right?
Yes.
They will be cancelled. So this will be cancelled with this 1, and ultimately you will get 1 plus sine power 4x minus sine square x. But after this, what you will do?
We'll take sine square common.
From this one,
Sine
okay,
square.
I'll take 1 sine square x common, took sine square x common, it has become sine square x minus 1. After that, if you say you can, if you want to continue, you can write it like this: 1 minus 1 plus sine square x, and 1 sine square x minus 1 you can write as minus cos square x, right? So this one you can write as 1 minus sine square x cos square x. But after that, what you will do? So ultimately, this thing has been converted into dx by 1 minus sine square x cos square x. But now what?
So we can substitute something.
That's what you have to think. Think and then tell me what you will substitute so that this integral becomes easy.
1 minus sine square x.
Where? In, in place of cos square x.
We can take cos square, or we can take 1 minus sine square x is equal to t.
But how? How you will take? If we take 1 minus sine square x is equal to t, then what you will do?
Okay, we can't. So then we'll take cos square x only.
See, because this is one entity, sine square x into cos square x.
Yes, sir.
Uh, I am telling if what good it will give you if you are doing 1 minus sine square x is equal to t, or you are taking cos square x is equal to 2, what it will do for you, how it will be helpful for you. Actually, I had entirely different idea in my mind to solve this one. What you know? After this, see, if we go by your method, you have got stuck at this particular place. If you want in this place, what you can do is you can divide the whole equation, the numerator and denominator, by cos power 4x. So you can get secant power 4x dx divided by secant power 4x minus tan square x.
Dividing the whole equation by.
See, I have divided the numerator and denominator whole by cos power 4x.
Okay. Cos 4x. Okay.
Cos power 4x.
Yes, sir.
So this will become the numerator will become cos secant power 4x, and the denominator will become secant power 4x minus tan square x. Correct, na?
Yes, sir.
Now what you can do, you can take now secant square x is equal to, because you know secant square x is equal to 1 plus tan square x.
Yes, sir.
So let the secant power 4x in the numerator as it is. 1 plus tan square x it will become in the denominator whole square minus tan square x it will become. Now just expand this. It will become integral secant power 4x dx divided by 1 plus tan power 4x plus 2 tan square x minus tan square x. So they will get cancelled. Now what you are getting integral secant power 4x dx by 1 tan power 4x plus tan square x plus 1. Now what I will suggest to you here, because tan x is there, secant x is also there.
Okay.
So you take tan x is equal to t.
Okay.
Once you have taken tan x is equal to t, if you differentiate on both sides, you will get d by dx of tan x will be equal to dt by dx. So it will become d by dx of tan x is what? Secant square x.
Secant square.
So secant square x will be equal to dt by dx. So it means secant square x dx you can write as dt. So here in the numerator we can write secant square x into secant square x dx will be dt divided by t square plus t plus 1. No. T power 4 plus t square plus 1.
Yes, sir.
Since and also because we want to convert this whole equation in the form of t only, secant square x I'll write as 1 plus tan square x. So it will become 1 plus t square into dt divided by t power 4 plus t square plus 1.
Yes.
Now this is very interesting. After this, what you will do, after this what I will do, because don't worry, this is actually new to you, and this questions if it comes for 6 marks. So after this what we will be doing, we will be dividing numerator and denominator both by t power 4.
Three power. Okay, sir.
So it will become 1 by t power 4. mm, no, t power 4 or t square. We'll divide numerator and denominator by t square. So it will become 1 by t square plus 1 divided by t square plus 1 plus 1 by t square. You will understand why did I do this. Now see, numerator I have 1 by 1 plus 1 by t square dt, and in the denominator if I like I can write this as t minus 1 by t whole square. Wait, this will become t square plus 1 by t square. I can write minus 2 here, plus 2 plus 1 will become 3. I can write this equation as in this way. Correct?
Yes.
Now denominator, focus on the denominator. 1 by plus 1 by t square dt divided by this whole thing, this one. This whole thing will become t minus 1 by t whole square plus root 3 whole square I can write. Now it is very interesting. Why? If I take t minus 1 by t is equal to some p, some substitution, and if you try to differentiate this one with respect to t, what you'll get, 1 minus 1 plus 1 by t square. Can you see here why? So now when we have done this way, so now this integral will become integral dp upon p square plus root 3 whole square. Now do you remember this is the formula for what?
A square plus B square.
No, that one, integral dx by x square plus a square. The
Yes.
formula that you have just applied. So the
Yes.
answer should be 1 by a tan inverse x by a, right?
Yes.
Now if you substitute p, you will get 1 by root 3 tan inverse. P was t minus 1 by t divided by root 3 plus c. And now again we will substitute because we have taken t as tan x. So it will
Yes.
become 1 by root 3 tan inverse tan x minus 1 upon tan x by root 3 plus c. This is your answer.